I'm Darla Strauss. I'm one of the vice presidents of Bet Aviv, and I've been the sort of project manager of this particular grant program, and that we're thrilled that you're all here. Scientists in the Synagogue is sponsored by Sinai and Synapsis through the John Templeton Foundation and the American Association for the Advancement of Science. And so we've been able to have, with today, we'll have had 6 seminars as part of this program. And we are delighted to have a wonderful group of members who are here. And again, I wanted to mention a few guests and more guests coming in the afternoon because they're attending a religious service at another synagogue in the building, but then they're hopping over and they're going to spend time with us. For guests not familiar with the meeting house, a few people said, are there bathrooms? I said, yes, there are bathrooms, believe it. So if you just go out the back doors, turn a little bit to the left where the fireplace is and curve around, and there are bathrooms there. I also want to let you know we have security that is here with us through the whole day, and they know where everything is in the meeting house also, so you can ask if you're looking for something in particular. Quick agenda, very quick. We have Seminar 1 beginning very shortly. That ends around noon. We have lunch that follows that right in this room. There'll be a whole new setup of goodies for you to eat, a lot of desserts and beverages. I know you all brought your own lunch, which we appreciate very much. And you may be appreciative of it, depending on what's usually served for lunch at various places. So there'll be desserts and beverages. Seminar 2 begins at 1 o'clock and features astronaut Richard Arnold and Rabbi Joseph, who is here, as you can see, and is very, very important part of this seminar, every seminar that we've done. Our grant entitled Knowledge Unbound, Connecting the Worlds of Science and Judaism truly fulfills the purpose of this very unique grant program, which actually asks the recipients of the grant to introduce science topics, primarily utilizing the knowledge and the expertise of scientists, retired or not retired, that are members of our own synagogue or are part of the synagogue community of friends and or family. Also very important to the program is our rabbi. She didn't even smile about that, but very important, who has the role of examining each science presentation in light of the teachings of Judaism. That is, looking at connections or disconnects through the lens of traditional theology or more contemporary interpretations and writings. This is not often an easy task, but one that takes time, research, and knowledge, and I think all of us would agree Rabbi Joseph has done a fantastic job and will continue it through today. You are going to learn today about creation, and I'm probably off base a bit then and now, but just a general idea. And also in the afternoon, hear from someone who has seen our planet from above the surface, and actually, as he was mentioning, he's seen it below the surface as well, and maybe he'll touch on that as well. Each of the seminars has a question and answer period folded into it. We have a microphone. I have a cordless mic that now can reach all around the room. And so we hope you'll think of great questions, because that's a lot of the extra fun and excitement and learning that takes place. So now let me introduce our morning presenters. First of all, I'm going to start with Rabbi Joseph. Now, it's a little bit redundant, but not really. We have a lot of other people who don't know the rabbi, and we'd like to hear about her. So Rabbi Linda Joseph is celebrating her 30th year as a rabbi. She looks too young for 30 years. What do you think? Currently, she is our rabbi at Bet Aviv in Columbia, Maryland. She's also employed as an instructor for the Union for Reform Judaism's Introduction to Judaism program, and she tutors Hebrew for B'Yahad, I hope I did that right, the Jewish religious school here at Oakland Mills Interfaith Center. Rabbi Joseph has many passions, very passionate about God and the representation of God, the Jewish people, Jewish traditions, and Jewish text. She enjoys teaching, prayer, community, connection, storytelling, making art, listening to music, writing, reading, traveling, and cooking, and she never sleeps. So she just does this all day long. Born in Melbourne, Australia, she first came to the United States for rabbinic school at the Hebrew Union College, Jewish Institute of Religion, in 1990. She has served congregations in the United States and in Australia and was a regional director for the Union of Reform Judaism when that structure existed. She lives in Reisterstown, Maryland with her husband, Richard Landis, a retired lawyer, and her dog. And now it's what you would read would be the doggy's name is Ben Bagbag, but the Hebrew pronunciation is Bug Bug. So, and it's a really cute little sweet dog, I have to tell you. So you wanted that dog to come here, didn't you? I can see. Now let me have the pleasure of introducing Dr. Richard Madonna. And Rich Madonna has been a member of Bet Aviv and served as president of the congregation for 2 years, and so many of us know him, but we really never knew him in terms of his professional background. So I hope you enjoy me filling in those blanks. Richard Madonna holds a BS, MS, and PhD in physics. His PhD is from Stevens Institute of Technology, and his thesis addressed, get ready, general relativity for the computation of gravitational waves from different types of slowly moving systems. I have a slowly moving system, so I'm going to ask him if he can help me. If he can help me. He also has earned his MBA from Long Island University. Richard served on active duty as captain in the United States Air Force, conducting R&D activities in support of a national security mission. His duties included the manifesting and support of a space shuttle mid-deck radiation detection payload that was flown on 10 shuttle missions. It's cool. After leaving the Air Force, Dr. Madonna joined the Grumman Aerospace Corporate Research Center, where he researched several different technologies and developed a remote sensing research program for the company. He transferred to Northrop Grumman's Mission Systems sector in Baltimore, where he served as system architect on several space-based electro-optic and infrared sensing programs. In 2015, Richard was named as Northrop Grumman's system architect for the Northrop Grumman Caltech Space Solar Power Initiative. When he retired from Northrop Grumman, he joined the Caltech Space Solar Power Project team as project manager. And you know, he gave a speech to Teachers of the Year when I was back in the day, was the director of that program at the State Department of Ed, and it was so interesting in terms of capturing solar energy, not just on the roof of your house, but I think I've got this right, but what if it could light up a city? It was really terrific. He's responsible for systems engineering studies that examine how well the basic technologies and their variations perform when integrated into an energy delivery system. He also led the development of the Space Solar Power Demonstration 1 with the payload, which I just asked the definition for that, and served as the Caltech mission manager. Uh, Rich Madonna is the author of more than 50 papers, one book, and holds 3 U.S. patents. He's held adjunct faculty positions at Florida Institute of Technology, Rollins College Department of Mathematics, Hofstra University Physics Department, Johns Hopkins Whiting School of Engineering, and at University of Maryland, Baltimore County Systems Engineering Program. He's been an invited lecturer for graduate aerospace courses at the University of Maryland, College Park, and Caltech. Who has water for me? He's got a fabulous resume. Please warmly welcome both Rabbi Joseph and our own Dr. Richard Madonna.
So Darla went on so long that my batteries have gone.
This is not my fault. I introduced you guys properly, I was told.
Shabbat Shalom.
Shabbat Shalom.
Just give me a moment because I want to make sure the people online can hear me. Ah, dear. All right, they're the dead ones. These are the live ones. Okay, let's see. 1, 2. Shabbat Shalom.
Shabbat Shalom.
Okay. All right. Hopefully we won't have to do that too much today. We have very short life in these batteries. So it's so wonderful to see you all on this beautiful Shabbos morning, and we are about to study together for the day. So I would love you to join with me in the blessing for studying Torah. For those of you not familiar with that blessing, because I see we have a few guests and I don't know what you know and what you don't know, the ending of the blessing is la'asok, to busy oneself, b'divrei, with the words of Torah, b'divrei Torah. Please join me. Baruch atah Adonai Eloheinu melech haolam, asher kirishanu b'mitzvotav v'tzivanu la'asok b'divrei Torah. So when Dr. Richard Madonna and I were preparing this, we were sitting around my kitchen table and we were having this dynamic conversation. And I said to him, you know what would be fun? It's for us to just prepare some stuff and have a dynamic conversation in front of everybody. So this is going to be very informal, less lecture-like and much more informal as we explore together a discussion about the scientific and Jewish perspectives of creation. And I'm going to let Rich start, and then I'll interrupt him lots.
Thank you, Rabbi. Shabbat Shalom. Good morning. Thanks for coming.
Is your microphone on?
Is it on? Can everybody hear me okay?
Yep. Excellent.
Yeah, good. Okay. So we decided that it might be more interactive for everybody to have this discussion. I just want to start out by saying a couple of things before we actually start talking about cosmology, which is what I'm going to talk about. I'm going to try very hard to avoid using the word creation because physics ends when you invoke creation. So I am going to try to stick with science as it's known today. And having said it in that way, the key emphasis is as it's known today. Science changes. Science is a dynamic process of discovery. And as we learn more, we find often that what we've learned in the past or what we thought was true is not true. So for example, could you put up the slide with the Ptolemaic universe?
That one?
No, the next one.
Next one?
Yeah, that's got a build on it, though. You don't have to. Sorry. So, back, 3,000, 4,000 years ago, that was the accepted picture of the universe. And we all know today that's not the accepted picture of the universe. And this picture of the universe persisted into the 1500s. Copernicus's work was banned by the church. Galileo, of course, had his famous run-in with the Pope. with Pope Urban III, I believe it was, because he espoused this heliocentric model of the universe, or at least of the solar system. But we know that's wrong. We know today that's wrong, but that was accepted science. So science is, first of all, hopefully self-correcting. It's a process of discovery. We ask questions all the time, and the questions that we often ask are about the accepted science, because that's where, when we find that the accepted science breaks down, we find out that's where there's new science. And so there's always this question about, I know what I know, but do I really know it?
That is so similar to what Judaism thinks. So let me bring up some of my slides. Here is, here is Maimonides' guide to the perplexed. And he talks about all this is in accordance with the teachings of natural science. So he acknowledges natural science. He's not against natural science. Judaism is not against figuring it out. We ignore for the present of the question whether we assume the eternity of the universe or the creation ex nihilo. So the idea is that science and Judaism come with different purposes. But following up on Rich said, the Tiferet Israel, which is Yehuda Lo ben Betzalel of Prague, you may know him as the Maharal. He writes in his Tiferet Israel that there are more questions than we have answers, right? Which is exactly what science says. He writes, but things are not so. For the natural things such as animals and even plants do not present to us with explanations and reasons. For how can it occur to anyone that they can give a sufficient explanation for every animal, the number of its tissues and organs, for each in its unique form? An explanation, and for all the plants. And do not look towards the doctors and the naturalists, for if they have given an explanation, it is for one case in 1,000. And even when they have given one, it's not clear what is true, as is known to anyone who studies their words. In other words, Jewish philosophers have often thought that we can't find out all the answers, right? That begins with the book of Job. Things are beyond our understanding. But we can ask questions and know more, which is exactly what science says, right? That it's not fixed, and as we know more, our understandings, they change. Let me go back to Rich's beautiful slide.
Let me jump on that other thought about not knowing everything, because this is also part of the discussion before we get into modern cosmology. We build, as physicists at least, we build models using mathematics to try to understand physical phenomena in the universe. So why do atoms radiate light when they're excited by some collision or by absorb some light? There's a model for that, and most of it's under the guise of quantum mechanics. I'm not going to talk about quantum mechanics directly. But in building a model, the model is an abstraction of the real world. So there's details that are left out that are considered maybe unimportant or confounding as you build that model. So the model is by definition incomplete. And as we start looking at some of the things that go into modern cosmology, what we're going to find is that we have an incomplete model to explain how the universe came to be what it is today. And that's where, again, the new science lies, is trying to make that picture complete. And then there's a famous theorem by a mathematician, Kurt Gödel, that says you can never have a complete theory. So, life can get very interesting, and it can produce lots of PhD theses. So that's a good thing.
Right. And I think Judaism says exactly the same thing, but it comes with a different purpose, right?
Right.
The purpose in Judaism is to establish proof, right? So here we have Sefer HaIkarim, right? We have already explained the first book that the Torah begins with the story of creation to prove the existence of the Maker. Judaism doesn't claim to be scientific. Judaism claims to be theological thought, right? The account of the way in which things pass from potentiality to actuality proves the existence of an agent who brought them into actuality, which I think is probably some scientists would believe that and some scientists would not. And the fact that they passed into actuality at different times, namely in the 6 days of creation, shows that the agent is one who acts with intention and will, and does things at different times as the Maker's wisdom dictates, though they could have all come into being at the same time. So there's this openness in Judaism about how creation happens, and we'll talk about that because there's a number of different creation stories in Judaism. But all of those stories, the purpose is one, and that is to prove that there is an existence of a maker, that you can't get back to that original point without an existence of a maker. Now, some scientists would agree with that, I think.
And some wouldn't.
And some wouldn't, right? Depending on the aspects of how they understand faith. Yeah.
Can you help, since we're talking now about getting to the topic, so can you hop to that Big Bang chart?
This one.
No, the one with the picture, the universe.
Okay.
Yeah. So I'm going to talk
All right.
mostly about the Big Bang Theory today. I want to start by saying this is sort of the mainstream theory, but there are problems, as there are with most theories. And there are alternatives. I'll show a picture of an alternative. Can you hop to the one that's the big bounce?
The big
Bounce.
bounce. Is that this one?
That's that one. So that's an alternative. I'll talk very briefly to this, and later we'll talk about why this is in vogue. This shows a picture of a universe that's already in existence that over time collapses, but not down to a small, an extremely small region, but a small region of space and time, and then blows up again. And this is actually being a fairly active area of research because it addresses some problems that emerge in trying to put together the Big Bang picture. And one of the things I will be very open about is where the problems in these models lie and why that's driving a lot of research. And one of the things I will also keep pointing out is that when we get a model that we like as physicists, and then it tends not to work somewhere, we tend to, rather than abandon it, we try to patch it. We introduce new things and that fix that problem. But then they somewhere downstream create other problems because as much as we teach physics as like blocks of information, we talk about electromagnetics, we talk about mechanics, we talk about thermodynamics, it's actually all connected. It's actually you have to look at it from a more broader view. And so when you patch something, you're eventually going to create issues somewhere else. So let's go back to the Big Bang.
I want to stop you there, though.
Okay.
Because I think, let me pull this one up. Here we go. This idea of universes bouncing off each other and then growing and contracting is also found in Judaism in some of our thoughts about creation. Not that it talks about exactly the same thing. It doesn't do it from the scientific point of view. This is from Bereshit Rabbi, a text composed in Israel and Babylon around 500 of the Common Era. So it's an old text. It's a midrash on Genesis. And here we have in Bereshit Rabbi this. Rabbi Yehuda bar Simon said, "It will be evening," is not written here, but rather it was evening. From here we learn that there has been an order to time even beforehand. And then Rabbi Abahu said, and this is where the parallel comes in, this teaches that God continuously created worlds and destroyed them, right? You've got the creation and the destruction until God created the current one and said, this one pleases me. Those did not please me. Rabbi Pinchas said the source for Rabbi Abahu is God saw everything that God had made, and behold, it was very good, which means this pleases me, and that didn't please with me. So when we have this idea of contraction, and we have this idea of growing, here we have God's destroying worlds, taking the bits, making a new world, doesn't like it, destroys it, makes it again, right? So that's very similar. It's not quite the same, but it's a similar idea of that back and forth.
So back to Big Bang.
Back to the Big Bang. All right, Richard Madonna's slides.
By the way, there is an alleyway in Pasadena called the Big Bang Way, Big Bang Theory Way. We've had breakfast, Susan and I have had breakfast at a cafe there. Okay, so let's start with the Big Bang Theory. And the whole premise of this theory can be traced back, at least in scientific literature, to somewhere in the, I guess, a Belgian priest in about 1931, I think it was, Lamartine, who said, looking at Einstein's theory and the work that had been done up to that point, said the universe probably started from a single atom that exploded somehow. So in the current Big Bang theory process, the universe at time equals 0, there is no time running, is all contained in a tiny little point. It's all energy, there's no matter, and then for some mechanism, and what has fallen out of favor now is something called quantum fluctuations of the vacuum, causes this thing to explode, and space and time and all this energy come into start to occupy a bigger volume. And the good question is, a bigger volume of what? And then, of course, somebody like me goes, well, this whole thing's embedded in a 5-dimensional space, and so it's just going into this 5-dimensional space, but that doesn't really answer your question. So we'll just leave that question
I'll
alone
get there
for now.
because Judaism believes in a 10-dimensional space.
Well, string theory's got 26, so. But, so this event occurs and the universe is, quote, born, and time starts running and things move forward. Now, this is an interesting time from a physicist's perspective because all our laws, all our theories, the things that we accept as common physics stop being valid at about 10 to the minus 34 seconds after the Big Bang. The energies are so high, the density of energy is so great, we're not sure the laws of physics actually are the same at that point. So we can't say anything conclusive about what happens prior to that time other than something happened. So the universe is in this dense state, it's energy, it's starting to expand, and it starts to expand rapidly. And I'm going to look over my shoulder here. And what happens somewhere around 10 to the minus 33 seconds, really small times here we're talking about, is there's a period that's thought to explain why the universe is as big as it is now. There's a period of rapid inflation. And by rapid inflation, I mean the space and time stretch out faster than the speed of light. No energy moves at that point, at that speed, but space and time itself move out faster than the speed of light, and they do that exponentially for many, many tens of minus 30-something seconds until it starts to cool again, and the inflation stops, the energy catches up, and then the universe starts to heat again. Now, that's important because without that inflationary period, we can't explain why the universe is as big as it is today. And hence the big bounce theory that I showed you is one of the attempts to overcome that problem because certain other things happen with inflation that I'll talk about in a few moments. But one of the things inflation does, and I use the phrase quantum fluctuation of the vacuum, inflation, when it happens, freezes these quantum fluctuations and then stretches them. So think of a scar that you got when you were a tiny kid, and now that you've grown and you're bigger, that scar has stretched out on your skin. It's still there on your skin, but now it's a lot bigger. Well, these quantum fluctuations define where mass and energy will concentrate in the older universe. They get stretched out in space, and they form the centers for where things are going to happen later on in life. Now, the reason why the Big Bounce is brought in is because when we look at the remnants of the Big Bang, which is really 300,000 years after the Big Bang is what we can really see, we see a cosmic microwave background, but the uniformity of it doesn't get explained by inflation. So the Big Bounce kind of was put in because it does explain that uniformity, but again, we don't have evidence for the Big Bounce.
So let me talk about the Big Bang because we have a story, a creation story, a creation myth. It comes from around the 16th century, which predates this theory on the Big Bang by a long way, right? From Chaim Vital, who is a Kabbalist. And he says this, he talks about an infinite light, and he says, know that before there was any emanation, there was anything out there, anything had become, and before any creatures were created, a simple higher light filled everything. The idea that there's this pinpoint of light. And there was no empty form of space in the form of a vacuum, but all was filled with that simple, infinite light. And the infinite light had nothing in it of beginning or end, but that was all one equally distributed light. And this is known as the light of the Ein Sof. Ein Sof is one of God's names. It means the one without end, the infinite. And then there arose in Ein Sof's will the will to create worlds and produce emanations, right? Something that comes out of Ein Sof in order to realize perfect acts. Ein Sof's names and Ein Sof's attributes. And this was the purpose for which the world was created. Once again, we get back to the idea that the proof, right, the creation of the world is a proof of God. Ein Sof's being then concentrated in the middle point. So you imagine this infinite light, no room for anything. Ein Sof contracted in the middle point, and you can see that middle point. Let me show you here. The middle point is just here, right? If you think about Ein Sof being here, and then here's a middle point, right? Which was at the very center, and Ein Sof withdrew that light, remaining it in every direction away from the center point. And then there remained around the very center point an empty space, a vacuum, right? This withdrawal was equidistant from the central empty point, so that the place left empty was completely circular. And you can see that the middle point is circular, right? We have this light and we have this circular bit. It was not in the form of a square with right angles. We're confirming here it's circular. The Ein Sof withdrew in a circular fashion, equidistant in all directions. Now, after this withdrawal of the Ein Sof, there remained a place in which there could emerge things to be emanated, to be created, to be formed, and to be made. And then there emerged a single straight line from Ein Sof's light, straight line, right? And this came downward in direction, winding into the empty space. And the top end of the line derived from the Ein Sof and touched Ein Sof, but the bottom end of this line down below does not touch the light of the Ein Sof. By means of this line, the light of Ein Sof is drawn down to extend itself down to below. And into that empty space, Ein Sof caused to emanate. And here we have all the emanations. Any of you that know about the emanations of God or the Sephirot, we can see in this picture the different emanations. And Ein Sof created. And then Isaac Luria, also known as the Ari, takes this idea a little bit further. Into the void made possible by Tzimtzum, divine contraction, that was the light coming into that small point, God set vessels, kelim. And if we go back to this picture here, each of these colored lines is the kelim, and each of those are the Sephirot, right? Right? Or bowls, intended to fill them with creative light. At first, the beams from the divine ray poured into the void as planned. It looked beautiful. It was that circular thing we saw before. Then suddenly something unexpected happened as all the light contracted into those 10 vessels, right? You talked about 5, I'm talking about 10. A cosmic catastrophe which even the Ein Sof hadn't intended. The cascade of light was so powerful, the vessels could not contain it, and they shattered in a great explosion. It sounds like a big bang, doesn't it? Yeah. And some of the light retraced its path back to the source, but the rest was scattered and became trapped in the strewn shards. Think about pottery bowls breaking, right? And you've got these shards everywhere, and they're strewn all over, which now littered creation. And these shards containing divine light are the stuff of our material world. We are made from that shattered light. Yeah.
We are stardust.
That's stardust,
Yeah.
right? You want to talk about stardust?
No, not yet. Too early.
Okay.
We're still not quite out of.
We're back to the Big Bang.
So we have this inflationary period, and and then things begin to start to cool down. Now, the rabbi mentioned light. The energy at this point that's floating around the universe is so high, it's not really light. We would be just vaporized by it. Light doesn't, what we think of as light doesn't come into existence till a little later on.
But I would say that God's light is not light as we know it either, right?
Right.
God's light, I mean, when we think of light, I think this is divine light. So it's not the same as light as we think about it.
So, and could you pull, there's a thing with arrows.
A thing with
The fundamental force chart.
this one?
That one.
Yep.
Yep. So, going on at the same time, and probably you all learned at one point there were 4 fundamental forces that govern the universe, gravity being the weakest, electromagnetism being the next weakest, both long-range forces, they have infinite extent. A weak force which modulates how certain nucleons interact with each other, and then a strong force which is the binding force for the nucleus, for things like protons and neutrons being bound together in a nucleus, and extends on into the quark theory of hadrons and mesons, which became verified in accelerator experiments starting in the 70s. So these 4 forces are thought to be one force back at the start of this whole Big Bang process. And as the universe cools and expands, these forces start to separate out. And the earliest force that separates out, surprisingly, is the weakest one. It's gravity. And gravity starts to dominate about the time that inflation stops and the universe starts cooling, because matter starts to begin to form. So there's enough cooling now where the energy, where particles, these energetic particles coming together, passing each other, can interact and using E equals mc squared create matter. The matter doesn't last very long until the universe cools more, because another energetic thing comes along and converts it back into energy. But this process goes on and the universe cools, and eventually there's a period called baryogenesis, which has several different models to describe it, but none have been. Again, this is a point where we can't make measurements to verify one model over another, where it explains how matter kind of came to form. And one of the questions that's still open with this baryogenesis period is, if you look at all these theories that go into this cosmology, one is the relativistic version of quantum mechanics, which says that if I create a particle, if I create mass from an energetic photon, let's say, a light particle, I should create a particle of matter and a particle of antimatter to conserve energy. Well, in a dense universe, those 2 particles are going to come back together again and go back to energy. So the question becomes, we look at the known universe through astronomy and things, we don't see a lot of antimatter in the universe. So why is the universe made of matter? Where did that antimatter go? Is there some other physics that we don't quite understand? Because all you need is something like 1 part in a billion difference to have the universe become matter dominated, or if it goes the other way, antimatter dominated, although we wouldn't know we're antimatter, we'd just say we're matter. So this baryogenesis period is very important from that standpoint, because the universe becomes matter as we see it today, and it cools more. And then we move into the next period, which is nucleosynthesis, and that's when matter is stable long enough for protons and neutrons to start to come together and form atomic nuclei and eventually capture free electrons to make the primitive atoms. So mostly helium, hydrogen. The dominant element in the universe is hydrogen. Helium, hydrogen, lithium are early elements that are formed, and that's at about 300,000 years after the Big Bang. Now, that number is important because when these atoms form, they start to radiate light. They're interacting with still all these other photons that are running around. Now they've cooled a lot. They're not destroying the atoms, but they're causing the atoms to, the electrons in the atoms to get excited. What atomic physics tells us is that excited atoms jump up into a higher state in the atom. Because the atom wants to be at a lower energy state, they radiate a photon out and decay back to the ground state, and they emit light. And that's the basis of a lot of the lighting systems we use and things like that. So that light was there, and it's really light now that you can see with your eye. And that light now, some 14 billion years later almost, forms what is called the cosmic microwave background. And so the measurements of that background kind of tell us that at least up to that point, that 300,000 years, we know atoms are forming and they're radiating, and we can verify that much of the theory experimentally from that observation. And that observation, by the way, was made in New Jersey at Bell Labs, for you Jersey guys out there, by Arnio Penzias and Wilson. They received a Nobel Prize. They were two Bell Lab engineers who were working on microwave communication for satellites. They had this big microwave horn sitting out in the field there at Murray Hill in New Jersey. And when they first saw they pointed at empty sky, and when they first saw these signals, they attributed it to a dielectric substance on the antenna, which was polite speak for bird poop. But they won a Nobel Prize because they were able to verify that, yes, indeed, this was coming from the background. And there have been another Nobel Prize awarded to Goddard Space Flight Center, I forget the investigator's name now, for a satellite sensor that he developed to map it more accurately and show the uniformity of the microwave background.
So it's so funny that later on this afternoon, I actually have a song being sung by Shifra Penzias, who is his daughter, who is a rabbi I went to rabbinic school with. So there is connections everywhere. The idea that there are elements that
May I
create...
interrupt you one more second?
Yep.
I realize there's something I meant to do. I used a phrase twice without defining it, so let me back up. I used the phrase quantum fluctuation of the background, and it's a nice word, but you're still going, okay, I know a word, I don't know, or words, I don't know what they mean. So I'm going to try to make this fairly simple with, and no math, my fingers will never leave my hands. So in quantum theory, and especially in the relativistic version of quantum theory, there's this thing called the Heisenberg uncertainty principle, which many of you may have heard the words. And what it boils down to is in quantum mechanics, it's not a deterministic theory, which means if I say A happens, so B will be the result. Instead, in quantum theory, you say A happens, and there's a list of things that could happen as a result of that, and there's a probability associated with each of those things. So I don't know what is going to happen when I do A, but I can predict with some probability what might happen. But along with that goes this idea of a vacuum in physics is just empty space. There's nothing there. There's no energy. There's no matter. But that means I know precisely the energy of any point in space. I know exactly what that energy is at that time. I know the momentum of that point in space at that position, and that violates the uncertainty principle. So because Heisenberg is one of those people who's privileged to know more about the universe than the rest of us, space does this thing called quantum fluctuations in the background. So particles pop into existence from the vacuum, and then they annihilate again, going back into the vacuum, but they don't stay in our reality long enough to violate conservation of energy, conservation of momentum, or any of the other conservation laws. So the vacuum is not a quiet place. It's bubbling all the time. We just never realize it. Now, if you put a strong energy source or something that can interact with that, you can extract particles from the background, and that's the basis of Hawking's black hole evaporation, is that quantum fluctuations occur near a black hole, but the gravitational field's so intense that one of those particles gets pulled into the black hole, it becomes real, and the other gets kicked away from the black hole, it becomes real, but it uses energy from that black hole to do that. So the black hole gets smaller as a net result. So this quantum fluctuation of the background is important, as I said, because in cosmology, these fluctuations get frozen in at inflation, and then they form the seeds for where matter is going to clump and collect, and gravitation then will start to build things like stars and planets and galaxies.
Okay.
Sorry.
No. So now I want to bring in a number of different texts. We talked about there being nothing, right? In the creation story, let me go back to the creation story, because most of you will be familiar with it, and I did actually put it on slides. You're familiar with the 7 days of creation. When God began to create, we notice that it says here in verse number 3 God said, right? And in the creation story, in the first 6 days of creation, God said appears 10 times. Why I'm telling you that from the Genesis story is we get this teaching which comments on the Genesis story with 10 utterances, ma'amarot, the 10 sayings, right? The world, God said 10 times, the world was created. And what does this teach? For surely it could have been created with one utterance, one ma'amar, right? But this was so in order to punish the wicked who destroy the world that was created with 10 utterances, ma'amarot, and to give a good reward to the righteous who maintain the world that was created with 10 utterances, ma'amarot. So we get the idea that God creates from nothing but creates something. So the question is, what is it that God uses to create from this nothing? And Sophono says on Genesis 1:2, V'ha'aretz haita tohu vevohu, and the land was tohu vevohu. We don't really know how it translates, but null, void, nothingness, right, might be the best translation we have. This very center, which was created at that time, was composed of a mixture of raw materials known as tohu, and its original external appearance is what is described as vohu. We still don't know what they are, right? The reason is that the whole expanse of tohu was comprised of a uniform appearance. This explained that the first raw material was something entirely new, right? It came out of nothing. These new elements developed. And it is described as tohu to indicate that at that point it was merely something which had potential. The potential not yet having materialized, being converted into something actual. Now, what is the actual according to our tradition? It's not those elements that you mentioned. What it is, let me find the right slide. Here we are from Sefer Yetzirah. It's the letters, right? Each letter being something. Of the 22 letters we read in Sefer Yetzirah, remember these are lots of different versions of the stories of creation that I'm bringing you, but all of them have their parallels in science. God drew them, the letters, hued them, combined them, weighed them, interchanged them, and through them produced the whole creation and everything that is destined to come into being, right? From these elements, which our tradition understands as the letters that you see in the Torah, right? Everything is there. By means of the 22 letters, by giving them a form and shape, by mixing them and combining them in different ways, God made the soul of all that which has been created and all that which will be. And it is upon these same letters that the Holy One, blessed be God, has founded God's high and holy name. So we have this idea that the world was created out of some sort of elements. You call them, what did you call them?
Baryons.
Barium and...
Baryons, hadrons.
Baryons.
Hadrons, yeah.
We call them the letters, right? Letters? Yeah. Let's go back.
Yeah. Could you pull up the cosmic microwave background picture?
Cosmic microwave, is that the one that I just had up?
No, it's
This one?
that one.
Yep.
So I mentioned the cosmic microwave background. This is a depiction of a survey that was done. I think this is the one. This is the ESA sensor that was flown recently that shows the whole sky. So this is the whole sphere of the sky mapped out onto a plane, much like you'd look at the map of the Earth. And it shows it's pretty isotropic. It's pretty homogeneous. And these colorations, blue is cooler than is cool, and red is hot, and in between. But you're looking at tenths of a degree of Kelvin, which 273 degrees Kelvin is 0 degrees Celsius, which is 32 degrees Fahrenheit, roughly thereabouts. And so you're looking at things that are on the degrees of a tenth of a Kelvin, and around about a temperature of 2.9 Kelvin, almost absolute zero. Absolute zero, there's no motion, there's no energy, there's nothing. So this is that light that was emitted 300,000 years after the Big Bang that we see in the sky today. Now, why don't we see it as light? Why do we see it as microwaves? it's moving away from us. It's at the edge of the universe, but it's radiating uniformly, and it's redshifted because of that motion. So the redshift is the shift is due to a guy named Doppler. He discovered the effect of shifting of a frequency or a wavelength as the source or the observer of that thing is moving, and it shows up in almost anything you think of. A siren from an approaching ambulance is a good example of a Doppler shift. You can hear the ambulance approaching, and the pitch of the siren seems to increase as it comes toward you, and then it seems to decrease as it goes away from you. Same thing happens with light. So this is the light from 300,000 years after the Big Bang, which is as far back as we can see right now because there was no really light before that. And it's now shifted down into the microwave region, so it's not visible to our eyes.
And so I think this is where science and the Jewish myths about creation, and remember there are multiple myths of creation, not just the Genesis 1 story. This is where they differ. Let me go back to my picture of the Ein Sof, right? The Ein Sof was in everything. There was nowhere for it to expand, right? It had to contract so that the universe as we understand it, right, can exist. But the Ein Sof is everywhere. And even once that Big Bang, right, that the Shvirat Kelim, as we call it, the breaking of the vessels, happens in Judaism, that is still everywhere. All those sparks are throughout everything. So there's nothing, you're talking about an expansion, right?
Right.
In Judaism, there is nothing but God. There is nothing but God. That's the Hasidim talk about it. Certain philosophers talk about it. Everything is God, right? And that's a difference. That is a big difference of understanding.
I'll add that picture of the microwave background is one of the reasons why the Big Bounce is being looked at, because the Big Bang does not predict that kind of distribution or that kind of uniformity that we're measuring. So again, is this the complete story? No, it's the best we understand right now, and warts and all, this is what I'm kind of communicating. So can we go back to the Big Bang?
Yep.
So we've gotten to 300,000 years in just about an hour, which isn't bad. Considering the universe is 14 billion years old, we're making pretty good progress. We've got the first nuclei. We're now into the period where gravity is dominating everything. All four forces are now separate. Electricity and the electroweak force have broken off. The strong force has broken off. And gravity dominates everything. These quantum fluctuations that were frozen into the expansion, as I spoke about, have now started to allow these atoms to start to gravitate toward each other and clump. I'll stop at this point and say, with the splitting of the forces, one of the problems that exists and has existed for I don't know how many decades at this point, is we don't understand how to put gravity together with the other three forces. It's a problem, and the biggest reason why we don't understand it is gravity, as we understand it now, is not a force. Gravity, according to St. Albert, is a distortion of space and time, or space-time, by matter and energy, or as John Wheeler would say, matter tells space how to curve and space tells matter how to move. And so it's a curvature of the four-dimensional space the universe is in, caused by the presence of matter and energy, and they act on each other. So think about, if you put a bowling ball on a stretched rubber sheet, you'd have this depression. If you put a marble at the edge of the sheet, it would roll toward that bowling ball. That is kind of what's going on in a four-dimensional sense. And because space is now an active player as opposed to just an arena where forces are going back and forth, the act of trying to bring gravity, which is what's called a classical theory, into alignment with the other three theories, which are now expressed in quantum form, has eluded us. My thesis advisor did a lot of work on quantum gravity in his early years. He gave up on it because at some point you realize there's a trick in quantum theory called renormalization to get rid of infinities. You said, and you have, as one of my other professors noted, you have a finite number of runs to sweep a finite number of infinities under. But in general relativity, you don't. You said, so I realized there's no way you can renormalize one, and these infinities exist. So that's one of the problems that plagues all these models, is that we just don't understand how to unify them.
Which goes to the whole idea that both science and religion leaves us with more questions than it does answers, right? The purpose of Judaism.
Now my battery's dead. Well, thank you, sisterhood.
The fact is that, and we're now getting feedback.
Yeah, how is
under your seat, there is a black bag that has batteries in it.
Okay, I think Howie's
Adjusting it?
adjusting, I hope.
All right. 1, 2. All right.
Test.
I seem to be okay.
Okay, I think we're good.
Okay. Judaism is a religion of questions. It doesn't give you definitive answers. We don't read, for example, the Genesis 1 story literally. And I've already said to you, we have several versions of creation within Judaism. And all of those come with a purpose to teach us something, not to be literally understood, right? This is about theology. This isn't about how things actually happened. The fact that there are parallels is lovely, right? The fact that we can find parallels is lovely, but science is to prove exactly what happened, to understand how the universe works. Judaism is to understand how to live in the world that we are, that there are lessons for humankind. So it's we come at it from very different spaces, but it's lovely that there are some parallels.
I think when we were discussing this around your kitchen table, you made the point that, I think it's in the Talmud, where it says that a day is not a day.
Yes. Shall we go there?
Well, I mean, we're talking about, we've gone from 10 to the minus 30 something seconds to 300,000 years, which is a pretty big span of time.
Right.
So yeah, we should probably talk a little bit about that.
Yeah, so you all know that, let me first of all go back to the story of Genesis, which I'm not going to go through the whole thing. It's long, and I think most people are familiar with it, right? But here we have, first day, second day, third day, fourth day, fifth day, sixth day, seventh day, right? Each section ends with there was evening, there was morning, a day, third day, fourth day, fifth day. There was evening, there was morning, a fourth day, there was evening and morning, a fifth day, evening and morning, a sixth day, at the bottom of this slide, verse 31, right? And people tend to think of day as something literal. But in fact, the rabbis very early on didn't understand that at all as it being a 24-hour day. And so let me give you some examples of text. Here is Sforno. Sforno is a commentator, 1500s, on Genesis 1, and he talks about time. Bereshit, at the beginning of time. This is the first moment which is indivisible into shorter periods. There had not been a concept of time previous to this. There'd only been continuity. God converted nothing into something. There had been no need to invoke time in order to accomplish this. So we start with this idea that there is no such thing as time. Once things came into being, time existed. Then if we go and look at Bereshit Rabbah, which is earlier, 500 of the Common Era, Midrash, they talk about this period of time. Rabbi asked Rabbi Yishmael ben Rabbi Yosef, saying to him, "Did you hear from your father what is meant by God completed Vayachel on the seventh day?" This is bewildering. The explanation is that it is like someone who is banging with a hammer onto an anvil. He raised it while it was still day and lowered it at nightfall. Rabbi Shimon ben Yochai said, A mortal human being who does not know with certainty their times, their minutes, and their hours, he must add from the profane to the sacred. But the Holy One, blessed be God, knows with certainty minutes, times, and hours, entered into it Shabbat like a hairbreadth. What is that telling us? This and similar passages tell us that God has God's own sense of time. A day for God is not the same as a day as we actually perceive it. And so this idea that in 24 hours God made heaven and earth, in 24 hours God, made the sun and the moon and the stars, that's not how the rabbis understand it at all. It's the day in God's time, which is not necessarily the day in our time.
So you're saying God obeys relativity.
Right. Let me just see. There's one more slide I want, and I'm not sure where it is right now. How the world was made, time. Let's see if it's this one. Nope. I've lost the slide. But the idea is, and I may find it again, is that there's another commentator that says something happened, God created, and then it might have been 4 or 5, 6, 7 or 8 days that creation might have taken into being, and then God starts a new endeavor. God creates land and sea, right? Starts it in one day. There's time that it evolves. Then God decides to create plants in one day. Time evolves. And it talks about this gap. It doesn't have to be 7 consecutive days. It could have taken multiple years, but there was a time when God decided to create that specific thing on that day, which is fascinating. All right, let's see if you've got the... Yeah.
Okay?
Yes.
Yep, good. Back. Yep, good. Okay, so let's go back to Big Bang.
Back to the Big Bang. Let's travel in time.
So we're now looking at galaxies. We're looking at stars getting formed. These start out as balls of dust, which then gravity compresses, and the hydrogen and mostly hydrogen starts to heat up because they're colliding with each other, and then as more and more mass accumulates, the pressures get big enough where hydrogen atoms have enough energy to actually fuse, and we get fusion occurring in the sun, the stars, and we get burning. And then the stars are massive enough that they start to attract each other, and we get galaxy formation. And in fact, I believe they just published this week or last week, the Webb just photographed the oldest galaxy seen. So it's back, I think they've dated it back to almost 90 million years after the Big Bang. So we're in this 100 million year era type thing where the universe is now coming to look like it does now. Now, one question you might ask is, well, how do we know that these are actually hydrogen and helium and things like that that are being burned in these stars, other than, we're extrapolating from the nucleogenesis period, synthesis period, because these things emit atomic spectra, and we can look at the atomic spectra through telescopes, and we can apply a Doppler shift, and they line up with the atomic spectra we measure in the lab of the same element. So we know that the elements are the same, which also supports the contention that we have. One of the assumptions we make is that the laws of physics are the same everywhere in the universe, because boy, wouldn't it be awful if they weren't. We would certainly have a muddle once we kind of got outside of our own little, area of the universe. So we know that part of the science is on pretty solid footing. So now the galaxies begin to expand, and they move away from each other, a fact that wasn't really known until 1925. And there's an interesting piece, again, science being self-correcting. When Einstein first published the general theory of relativity, which is a theory of gravitation, essentially, but it embodies all the aspects of relativity. He chose, because the current model for the universe was a static universe, everything was kind of in its place and it didn't move, except for planets revolving around the sun and things like that. But the galaxies were wherever they were, they didn't move. And then Edward Hubble came along in 1925, and through using atomic spectroscopy and looking at the Doppler shifts, he realized that all the neighboring galaxies were moving away from us. And the further back, the further away the galaxy was, the faster it appeared to move. So Einstein had to go back and add a term, which was allowed, into his field equations that explain that expansion, which is one of the reasons why he didn't allow Brandeis University to be named after him, which is a side story. But Brandeis University was supposed to be Albert Einstein University. He thought that given all the mistakes he had made, they would find out that most of what he had done was wrong, and why name a university after a fool? Very humble man. So we have this expansion, and more recently we have found not only are we expanding, but the expansion seems to be accelerating, which we don't quite understand. And so, and the galaxies, by the way, are moving too fast for the amount of mass that we can see visibly with telescopes and estimate from, again, spectral absorption lines and things like that in astronomy. So two things have come into play. One is called dark matter, which you've probably seen articles about or things like that, which is matter that's very cold and very non-interactive, that makes up most of the mass of these galaxies, and it's all around us, but we haven't detected it yet. And dark energy, which is causing this repulsion. Now, dark energy turns out to be necessary because Einstein added in this equation that allows for expansion, but there's got to be a source of energy for that expansion. And again, we don't know whether that's right or not, and maybe relativity, general relativity, for all of the things it has done so well and keeps doing so well, maybe it's not really correct, or maybe it's incomplete. And that's probably the more likely explanation. But here we are now, we're a few billion years out, the universe is expanding, and about 9 billion years or so ago, our sun decides to have babies, and our planetary system is kind of born. And so the Earth sort of settles into the rock that we live on today about 4 billion years ago, and then things occur from there on in, which is no longer cosmology. It falls into somebody else's bailiwick, and that's where my story kind of will stop.
Okay, so I did find the text about the time in between, just so that you know that I wasn't lying. There is a text from Bereshit Rabbah, and it talks about Rabbi Nehemiah of Kfar Sihon said, "For in 6 days the Lord made the heavens and the earth, the sea. The 3 items are the essential basis of creation of the world, and each one waited 3 days and then produced 3 products." And it keeps going on, 3 days, 3 products, 3 days. So there's this time in between after each day. They are not consecutive. But I wanted to talk about the expansion of the universe.
There's a question which is sort of related to this, but 3 is a prime number, and 3 gets used a lot in mystical and spiritual. Is that coincidental?
Yeah.
Or?
No, it's not. 3s, 7s, these are symbolic numbers, right? It just means within a period of time, but it wasn't just one day time.
Sorry, I had to nerd out on
No. So you talked about the expansion of the universe, and we have that idea also in our texts. Here is a summary of the Akedat Yitzhak. Creation is divided into 3 main phases, right? Creation of matter before the first evening. Its importance stems from the fact that something came to existence out of nothing. That's stage 1. Stage 2, from the Akedat Yitzhak, this is composed, just so you know, around 1455 to 1495. The development of original matter into something organized and functional, as well as the creation of creatures, inasmuch as it now assumes a purpose. This phase is something new and important vis-a-vis the first phase. So then we have, right, nothing, matter's created, something with purpose. And the third is the completion and self-perpetuation of the entire creative process. development of an egg into a living organism. Don't understand that as an egg, just saying it's a parallel. The whole process of procreation in nature, that there is some sort of expansion. Another example of expansion in Judaism talks about this on a spiritual level, not on a scientific level, obviously. This is from Dreshot Haran. Some of you may know him as Nissim of Gerona. He's composed in Barcelona around 14th century. The resolution is as follows, he writes. There is no doubt that the creation is the knowledge of nature, but not in the respect of men know it through research, but in the respect in which knowledge of it is hidden to research and accessible only through divine effluence. That is, all creations display two types of activities. One type resulting from their matter and the other from their form, which is their essence. Those activities resulting from matter can be understood through research and through a perception of the accidents of matter. So there is some sort of research that can understand, and there are other things that we cannot understand. And finally, Ha'emek Hadavar talks about this ongoing creation. Why is there ongoing creation? If creation is to prove the existence of God, ongoing creation is for God's glory. And Ha'emek Hadavar is composed around 19th century. The plain meaning is that certain things in creation were not yet complete. It was God's intention to create those things and then do the changes later. Sounds like me. However, a deeper explanation of the word to do is that doing sometimes implies bringing an object to its ultimate purpose. This stage is the true creation of something because without its purpose, it cannot be said to exist. Now, the purpose of creation is God's glory. As Isaiah says, everyone that is called by my name and whom I created for my glory, I formed him, yea, I made him. So, creation in Jewish philosophy is for the glory of God, right? For our partnership with God, to prove God's existence. But there is an ongoing creation, and that is for God's glory. And that is the expansion of the universe. It's the things that we create that are in our partnership with God. All of that is about the expansion. What is created is not static. It is constantly ongoing. Yes, my friend.
So let's I guess hop back to Big Bang for a
Oh,
wrap up.
let's go back to the Big Bang.
So we don't, at the end of this, there's universe is cold and dark. We still don't know what happens after enough time passes. There's three fates for the universe. One is it keeps expanding forever and it gets cold and dark. Eventually we run out of energy and everything just becomes, lifeless and meaningless, and it's really depressing. Another is that there's enough matter and energy that we turn around and we contract again, and we either go back to a point or we go into the big bounce like you saw. And the third alternative is we have just enough energy and just enough matter in the universe that we get to a certain size and it stops and it becomes static, like Einstein thought, like the model of the universe was when Einstein formulated general relativity. And it's all highly dependent on astronomical observations to assess how much matter is present in the universe. And as I said, right now we have this missing matter problem where we think we can fill it in with this dark matter thing, but there's no evidence that dark matter exists. And I hope by repeating these kinds of things, you're getting the sense that one of the things science requires is that you actually do an experiment that verifies that you get what you say you're going to get. Because if you don't get what you say you're going to get, then you have to go find a different explanation that gives you what you say you're going to get. So a lot of things that we are discovering or that we're postulating still needs to be somehow experimentally verified. And again, this comes back to an issue with whether it's Big Bang, Big Bounce, or some other model that starts with the universe being hot and dense. There's a limit to how far back in time we can see, because the state of the universe prior to this cooling period at 300,000 years is such that we cannot measure anything that would be remnant from that earlier period. So a lot of this, there could be many things that feed into that 300,000 year point that could be right.
It's tohu vavohu.
Yeah.
We don't know what it is.
We don't know what it is.
Right.
And we can again generate lots of PhD theses and such coming up with it, but as long as they all agree on what is present at 300,000 years, pick the one that you like and argue ferociously in its favor.
So I would say, in terms of the unknown end, Judaism has a real sense that we are on a linear timeline. There is a beginning of creation, and there'll be a time of redemption, right? But in terms of the universe, God has told us in Bible, post-Noah, right, that God is not going to destroy the land with a flood again. We are told in the Midrash that God saw this world and it was very good, right? We're told in Genesis, and then the Midrash emphasizes that. So the sense that there's going to be another contraction doesn't exist in Judaism, but that there's going to be an end that's uncertain, and that there is this linear timeline of existence is definitely there in Judaism. We don't live in a circular timeline of starting again. God created worlds and destroyed worlds and created worlds and destroyed worlds. God created this world and saw that it was very good and made us the partners in maintaining that world. Whole debate about whether we're doing a good job of that or not, right? But God is not going to be the destruction of this world in Jewish theology. Yeah.
So an observation, as much as spiritual and religious writing might invoke a sense of awe, one of the things that is humbling from my perspective, when I think about the science, is that the universe is comprehensible. Think about it. Why should we be able to comprehend the universe? Even more remarkable is why should mathematics work so well in describing that? And that's been noted by people much smarter than me about that. The fact that we can use mathematics to actually describe the universe and the process going on is in itself amazing. And you notice I never talked about where this initial clump of energy came from, because I said I was going to avoid the word creation. And so you have basically two choices in what you want to do about that, because I don't think science can answer that question. One is you can say, well, it's always been there and that's just how it's been. Or you can say there is a deity, a creator. Maybe it's not a deity, but it's a creator who put it there and imbued certain properties to it that became the physical laws that we understand. And the act of creation was not so much an active act at each step, but I set up a program and the program ran, and now it's running through its loops.
Right, and for that science, so I brought this quote from an article called "God as the Connective Tissue of the Universe" by Rabbi Mordechai Liebling, and he writes, Rabbi Arthur Green, among others, has begun to articulate a non-dual Judaism grounded in the teachings of Jewish mysticism. And this understanding of reality asserts that divinity envelops, infuses, and pervades all that is. The entire system of interbeing is a manifestation of the divine, and thus each evolutionary development is yet another expression of the source of life. Evolution moves towards complexity as well as a greater awareness of this complexity. So from a religious point of view, science is there. Science helps us understand it. But the important thing from a religious point of view, once again, is that God is the source. God is behind. God is everything. God is the interconnection. And we research to understand more, but that understanding more just creates more wonder and more questions, right? Which is okay. Shall we open it up to
I want
questions?
to make one other
questions?
observation.
Okay.
It's sort of a contrast in we walked through the Big Bang pretty quickly, but I think the one thing that before gravity breaks off as a separate force from this unified force that we believe existed at the start of the universe is being dominated by laws that apply at the microscopic level in our universe. So in our present day instantiation of the universe, basically the laws of quantum mechanics. We every day don't observe quantum mechanics as an everyday experience, which is why it's so hard to study when you come up as a student, because it's not your everyday experience. It's not intuitive. You know, if you throw a ball against the wall here, the ball will bounce back to you. In quantum mechanics, the ball can go through the wall with some probability. So at the very start of the universe, we're being governed by laws that dominate our microscopic world here, but it's dominating the universe's start. And then it's only later that the laws that we observe, we experience every day, mainly gravity and electromagnetism, begin to dominate the universe. And it's just, you think about the immense scale of energy being governed by laws that only work at microscopic levels today. It's just kind of, you know, the whole thing is.
And Judaism would say behind all of that is God.
And anybody who didn't understand anything, I will try to make you. I will try to make you feel better. Richard Feynman, Nobel Prize-winning Jewish American physicist, Jewish American physicist, once said, "Anybody who claims they understand quantum mechanics doesn't understand it."
Yeah. My friends, are there any questions that you have for both Rich and myself? We would be happy to try and answer them and even bring up the right slide.
Oh, good, because if no one had a question, we were going to ask Rich to go over his entire piece all over again.
You can see Rich and I have fun around the kitchen table.
Norm.
This is a great discussion. Thank you.
My question is for both you, Richard. Hold it closer. My question is both for you, Richard, and also for Rabbi Joseph. And when we're talking about the universe, we're probably just talking about the known universe. The Big Bang occurred in the known universe. So let's just, I'm going to make an analogy to make this question seem more understandable. Let's just say that 1 grain of sand is equal to an entire galaxy. And the entire universe represents all the grains of sand and all the beaches in the entire planet. Now, thinking about that, the Big Bang probably only occurred in maybe 3 or 4 grains of sand. And because it's so vast, how do we know that God is only responsible for those 3 or 4 grains of sand? And maybe there's billions of gods out there that have their little grains of sand that they deal with.
So my monotheism tells me that all is God. So that's my simple answer.
So I can't speak to the God part of it, but I will refer you to Robert Heinlein's Job, A Story of Justice, which kind of goes along one of your lines of questioning. But there is a postulate, I won't call it a theory, called the many worlds hypothesis, which started out as an explanation in the 50s about what happens to all these probabilities that don't get realized in a quantum system. And it's an interpretation of the Copenhagen School of Quantum Mechanics that say, oh, they go off into other worlds that we can't access because you have probabilities that are essentially exclusionary from each other, right? But that got a reboot with string theory, because string theory is the theory of everything that predicts nothing. And one of the reasons it predicts nothing is it predicts that there's 10 to the 500,000, so that's a 1 with 500,000 trailing zeros, universes possible. And so rather than be uneconomical and throw them all away, there's a many universe hypothesis where each of these universes are in their own little bubbles, and the bubbles kind of push against each other. And so there should be evidence in our universe of bubbles pushing against our universe's bubble. And there's actually been people trying to look for those things. There's been no experimental evidence to support it, but it's, again, as I mentioned, patching theories. This is a patch to try to resurrect string theory, which a lot of time, energy, and careers have been thrown into for probably not good reasons. I think that's fallen quite a bit out of favor at this point.
And whatever is right, all is God.
I love this.
On a counterpoint to that, and you heard me talk about this, a counterpoint to that, we're talking about science, was Simone Laplace's treatise on terrestrial mechanics, celestial mechanics, which was written in 1812, presented to Napoleon at the Royal French Academy of Science. And Laplace did not do the usual introduction proclaiming God and blah, blah, blah. And when Napoleon said, "Where is God in all of this?" Laplace replied, "I had no need for that hypothesis." So,
Uh-oh. Jim Strauss, you want to ask a question?
Yeah, Darla made me ask this question. But it's very interesting, and both the rabbi and Rich did a great job. But it seems to me that every religion is all belief. That is, you have to believe in God in order to be religious. And it seems to me that there's no overlap, really, even though you did a wonderful job of making an overlap. I mean, in the Bible, it says, "And God created man. God created a universe and destroyed the universe until he found out that there was a great universe." And in Judaism, as all religions, you have to believe in God.
No, you don't.
This
So,
person who is all-powerful.
So
And
what
how does it relate to science?
Right. So what I would say to you is Judaism is not just a religion. That's something that we developed as an idea out of the 19th century, right? There are Jews that believe in God, and I bet if I was to do a survey of this room, I would bet there are people here that Jews that struggle with God, and Jews who don't think about God, but they regard themselves as Jewish, right? Culturally Jewish, ancestrally Jewish. What I would say is the stories come to teach us something. The 7 days of creation at the beginning of Genesis teach us that there is some order in the universe, that things happen in some sort of order, that something needs to be created for something to be built on, right? That's the essence of that story. The story ends with with humankind being partners with God in looking after creation. In other words, it's our responsibility to look after creation. That's the purpose of that story, right? The second story, the Garden of Eden story, which is regarded as the second story of creation, which talks about the creation of man and woman, right? Speaks about the fact that people grow up, they mature, at some stage they rebel against a parent figure, at some stage they have to go out on their own. Does that sound like anybody that's raised kids here know why that story is important, right, as a model? The story of the alphabet of creation that I showed you from Sefer Yetzirah talks to us about the fact that there are elements in creation that come together, right? That different things, that there's not just, it's just not one thing, but there are multiple things in creation. If we think about the story of the creation of the universe through God withdrawing God's self, God Tzimtzum, and putting light down into the center, and there being a cosmic bang, right? That teaches us ultimately that not everything goes right, that there is a responsibility to try to put the things back together. It's our you've all heard this phrase, tikkun olam, That's where this theory, that's where tikkun olam comes from. By doing good deeds, we put all those shards back together and make the world right. God is central to these stories, but God is not the point of these stories. So even if you don't believe in God, these stories still come to teach you something. If you are a Jew that is committed to making the world right, you are influenced by these stories. If you understand that any project you do has to have a beginning, a next level, a next level, a next level, and some sort of creation that comes out of that, you are the heir to these stories, right? These stories are still relevant, and that's the beauty of our stories. Yes, God is a central Jewish belief, but unlike Christianity, where you have to have faith in God to be Christian, or unlike Islam, where you have to be subservient to God, in Judaism, we are Yisrael. We are the ones that struggle with God, and God is part of our story. But even if we're in that struggling place, even if we're in that struggling place, the stories still have relevance to us. And we don't take them literally, right? Because they come to teach us lessons.
I think that's an important point because every religion has a creation story. And I think that's inherent to humans saying, you know, where did we come from? How did we get here? So there's every religion, even the mythologies that we no longer consider religions, have creation stories. Whether you, and it's whether you think this is, as in some religions, this is the literal word of God, so I have to believe it as it is written, or more, as the rabbi was saying, it's an allegory, it's a template, it's a framework for which to conduct your life and give meaning. That then becomes whether you really need to believe in God or whether God is a concept that helps motivate the rest of what you're doing. And so from a scientific as a scientist, I actually resonate with that more than anything else. And again, whether you need a God or not in science is beyond the realm of science to answer because it fails one thing. I can't test it with experiment.
Right.
That was great. Cal, come, let's see.
Cal always has great questions.
So, astronomy has looked at the universe, and they've begun to determine that star systems have planets, and they've recently discovered that some of these planets have chemical signatures that include all the constituents of life that is needed, you know, as we know it on Earth. So I'd be interested in, Rabbi, your perspective, in the Jewish perspective. Have recent Jewish thinkers considered the possibility of other life or other intelligent life elsewhere in the galaxy or the universe?
Wait, Cal, you're saying there's intelligent life here?
Maybe it's not so intelligent.
So there's great science fiction. I don't know of any Jewish philosopher that's working on that, but there is great Jewish science fiction written that it considers that. Maybe that's a parking lot question to look at Jewish science fiction at another time. But certainly there exists stories, modern stories that people have written that have considered that and considered how Jewish law might apply to that and how it might not apply. Like, there is great science fiction out there. So some people have been thinking about it. I just don't know any, and I just don't know any serious Jewish philosopher that I've read that has contemplated that.
It's a good question.
Yeah, no, it's a great question.
I have a question. I'm a little concerned about that Big Bang thing, sort of the end there that you didn't talk about, the sun blowing up or whatever, and the end of life on Earth.
Yeah.
I know that's a few years from now, but
Safe to say Social Security will be out of money by then.
so is that when God's going to decide we're kind of like not good and just going to get rid of us, or?
So I think Judaism is much more hopeful than that. So maybe this is a reason to go with Judaism over science. I think that God is hopeful that we are going to be good partners and we are going to do all the right things and the world will flourish and bring about that day when everything will be one long Shabbat and everything will be glorious, right? We have that. So I think that we have a more hopeful trajectory going on.
That being said, the sun's going to turn into a red giant in about 6 billion years, and the earth is going to go away.
I choose the hope. Judaism is a religion of hope. I choose the tikva, the hope, looking at the positive over concentrating on that negative.
Ruth.
Jim, a few minutes ago, referred to the concept of God as all-powerful, which I remember from my youth. And I was a little bit surprised when you talked, astounded really, when one of the theories that you had that circular slide up about light, the light emanating and then, yes, that one. And that something got out of control. How could that be with an all-powerful God?
Not everybody in Judaism believes in an all-powerful God. There are only 3 things that Judaism demands us to believe about God. And then there are lots of theories about God. What are those 3 things? Let me see if I can remember them. God is one. God speaks to us in some way, right? That's how we understand the mitzvot and the Torah and everything. God is one. God speaks to us in some way, but it's not defined. And God is one. God speaks to us in some way, and I can't remember the third. God is one. God speaks to us in some way, and I've gone blank. But being all-powerful is not one of those 3. And in other classes, I've talked about the fact if you believe God is all-powerful, then God, can you believe that God is all good? Right? There are contradictions in that. So you may have thought that God is all-powerful, but if that doesn't work for you theologically, I'd say let it go. Because people have been letting it go for centuries now.
We have a couple more questions. I know Bill does. Let me come back here to my friend Ronnie. My friend Ron.
How you doing? Yeah, I'm Ron Berkowitz. I'm an interloper from CJC.
Hi. Welcome. Good Shabbos.
One thing that struck me in particular, there are several.
Hold it too close to your mouth.
There are several. Rabbi Joseph, you talked about not having to believe in God to be Jewish. We got our congregation 55 years ago, got Rabbi Martin Siegel because he wrote a book, The Diary of a Rabbi. And there is one section in the book where Rabbi Siegel says a student came to him and said he can't be Jewish anymore because he doesn't believe in God. And Rabbi Siegel's answer was, you don't have to believe in God to be Jewish. So, and that was said a long time ago. I wanted to say that this presentation is absolutely phenomenal. This contrast between Judaism and science, it is just it's been a terrific program with a lot of different contrasting, and confirming ideas. One other thing I wanted to say, the thought of days in creation was particularly interesting in explaining these days are not the same the way we think of days. And I have a thought that creation didn't end at the end of the 7 days, and you all spoke about that. You also spoke about God trying several different creations until he got one he liked. However, I think for some of us...
I didn't say he got one right. I said he thought it was good.
Yeah, okay. All right. I stand. That even helps me explain what I have a crazy thought about. And this, my personal opinion, if this is what God thinks is good, he got a lot of ways to go.
So my answer to that would be, I think that this is good. I don't think that we are caretaking for it as well as we can, and we are messing up what was good.
Yeah, and in that light, creation is going on. And if there is a God, I think he's still working on it. And so at some point in the distant future, he'll get it right, and things will be good.
Yes. So let me go back to well, she's disappeared now, so you're going to have to relay the answer to this. I pulled up on my phone, because I can, the 3 acts of faith, and I went blank. All Judaism asks for us, and this is the only thing I can be to prove as true in terms of faith, right? I can't prove that God is all-powerful, all-knowledgeable. I can't prove that God created the earth. I can't prove any of that, right? But what I can say to you all is definite, and this is what Judaism asks. If you agree with any of these things, then you're Jewish. First is, we believe or wrestle with a belief in God. So belief can be part of it, but also wrestling, right? Mm-hmm. Does God exist? Mm-hmm. Do I really think that? Sometimes I do, sometimes I don't. You're allowed to be in that space. The second thing is God is one. Whatever we're wrestling with, it's unified, it's cohesive, it's not a multiplicity. It's unique, it's one. And the third thing is that God has something to say to us, right? That might be how Jewish tradition speaks to us. It might be we like to repair the world. We like to make it a better place. That's tikkun olam. It might be that we hear what is said in the texts and we like to wrestle with it. It might be following the 613 commandments, which some of them aren't relevant today because some of them belong to the temple, but however it is that God is conversing with humankind in some way through some form. As long as you believe those 3 things, that's Jewish belief. Now, when people come to me and say there is no God, I say, tell me about the God that you don't believe in. And usually, the God they don't believe in is the man sitting on top of a cloud. The God that has control of everything. And I'm like, I don't believe in that God either, right? But I do believe that there's some sort of unifying force in the universe. I do believe I wrestle with that. And sometimes I understand it one way, and sometimes I understand another, and sometimes I even doubt. And I do believe that through Jewish text, in my tradition, God is speaking to me in some way through the voices of my ancestors. And therefore, I'm firmly Jewish. If you can say that, then you are right in the middle of Jewish theology.
Love that. Love that. We have a chance for one more question.
So we can see that the two of you had a good time around the kitchen table. And thank you for letting us enjoy it as well. I'm wondering, to what extent has this dialogue been going on in two ways? One is people like Maimonides that had a foot in each world, but the other is sort of the influence. If we had a timeline of Ptolemy, Galileo, Einstein, and a timeline of the various texts, is it possible to say this is a philosophical response to Galileo or to Einstein?
So, I mean, based on the scientists that, I get to study because, going through school, you get educated, you build on the works of others. Some, there's obviously the mass of science in the early 1600s and such were dominated by Christians, at least in the Western literature. But with the emergence of the research universities in Germany, which is sort of late 1800s, late 1700s, early 1800s, Jewish people started to get more involved, and so you can start to see the emergence of Jewish scholars in science coming forward and making significant, in fact, radical contributions to the body of work. So in the more modern times, Einstein upset several apple carts in a matter of 1 year with 5 papers that were all Nobel Prize worthy, and relativity was not mentioned in his Nobel Award because of anti-Semitism, but that's a different story. Then you've had people like Feynman, Gamow, a Russian Jew, American Jew. You've had Silazard. Boy, there's just a list of European Jews who came to America in the 30s to get away from what was going on the continent, who all made fundamental contributions, and they were all educated as European Jews for the most part, so they've had some of this background. Now, whether they were religious or not, Feynman was definitely not an observant religious Jew. Einstein was raised and educated as a Jewish person in Germany and Austria, and he had a spiritualism about it. He did refer to God often, but when you kind of read his works, he's really talking about nature more than a deity. But he had the spiritualism. One of his famous quotes is, "I want to know God's thoughts, the rest are just details."
And I would say as early as the Talmud, even the Mishnah, we see that the rabbis are observing scientific practices and know of scientific practices that are happening around them. And that is true right throughout history. Sometimes regionally, there might be a differentiation. So for example, if we go to medieval times, the Spanish Jews tend to be far more immersed in science because they are far more assimilated into the Muslim culture, which is Maimonides, right? Well, if we look at Rashi and they are much more immersed in Jewish culture because they weren't allowed to be immersed in that wider culture. But they also know, like Rashi mentions medical terms, so there is some interaction going on. So they're not oblivious to the science going on around them. And once again, because Judaism is not literal, there is a much more openness to scientific theory, right? It doesn't, there's certain strains of Christianity that are very literal about the Bible, and we all know about them, right? They want the creation story taught as an alternative theory to the Big Bang, to science.
Intelligent design.
Intelligent design in school. I'm not against the idea of intelligent design. I'm just saying that I'm not sure exactly how
you can't prove the basic fundamental that there is a creator, because
right.
Once you take that away, it all falls apart.
But once again, I believe that God underwrites everything. The question is, how does God underwrite everything? And I don't necessarily believe it's day 1, this happened, day 2, that happened, day 3, that
And the interesting point about that is it says he created, but it didn't say by what means. And there is where I think you say, oh, well, here's the science, so God, again, set up a program. He built these laws into his creation, and the program ran.
Right, and so and also from very early on, it doesn't say a day is a day, or that the days were consecutive, right? I can.
That's true.
Right, so that allows a lot of room for me and for commentators in the past to embrace scientific theory and say, well, this is not so different to what Judaism says. I think the biggest difference that we had here is, I insist from the Jewish point of view that God is behind everything, that God is all, right? In science, maybe, maybe not.
Can't test it.
Can't test it.